Okay, guys. So phinde molweni njani? I'm good. We said we're gonna do the question properly, kahle na? Today. Okay. So it was question two, complex numbers. They say there an EMF represented by E is equals to 140,44 sine 314t plus 80,72 sine 1570t is applied. Okay, so this voltage, which is it's not a pure sine wave. Hence, we have two sine waves, which we call harmonics. Okay, these two harmonics make up this non-sinusoidal wave. And these two harmonics they make up this non-sinusoidal wave of a voltage. So if we have a non-sinusoidal wave of a voltage, definitely even the current will be non-sinusoidal. Okay, because current and voltage are proportional. Whatever the voltage is doing, the current will be doing the same thing. If it is increasing, maybe it's at a different amplitude. Even the current now is what? It's increasing. Okay, they are proportional to each other. So this non-sinusoidal voltage, which is made up of two harmonics, is applied across a resistor of 10 ohms in parallel with an inductor of what? 0.02 Henry. Okay. The question it calculates with the following. The power absorbed by what? What is absorbed in power in a circuit? The only quantity that absorbs power in a circuit, resistance. Okay, that is the only quantity that absorbs power. Uh, the inductor and capacitor they store the power, they store the energy, then they transfer it between each other. Okay. Um, then next question, need to calculate the value of the current supplied by what? By the circuit. Okay. So I want us to go here. So um, so we have a complex wave, né? We have a complex wave. Okay. 140. Yeah, sorry. Comma 44 is comma 44 sine 314t. And that is the harmonic yokuqala, ne? Okay, harmonic yesingaphi? Yesibini. Okay, let me. Sorry, it's 8. Okay. The second harmonic of this complex wave is 82, 80, comma 72 sine kt. Anna? Okay. Then let us draw our circuit. Yes. And also a resistor and a inductor. But they are connected in what? In parallel. So you see we have an AC what? We have an AC circuit. An AC circuit is a circuit, is the same as an ordinary circuit. It's just that the source is what? An AC what? Source. But this source is not giving us a pure what? Sine wave. It is giving us a non-sine wave. Okay. But this sine wave is made up Sorry, this non-sine wave is made up of two sine waves. That when you add together, they give you the non-pure sine wave. And these, we call them what? Harmonics. Prior, we have to determine which harmonics are there. Which harmonics that makes up this non-sinusoidal wave. Okay, for example, uh, I will always have Indoni, the fundamental, which is what? The first harmonic. How do you detect that? The fundamental, you look at the Indoni, the amplitudes. Okay. The one that has the highest what? Amplitude is the one that is Indoni, the fundamental, or the one that has the lowest angular what? Velocity is the one that is the fundamental. Okay, so the fundamental wave, sine wave, or the fundamental harmonic in this complex wave is this one. Yeah. So we want to determine which harmonic is that one. Okay. So we're gonna say 1570, which is this one, yeah? Divided by what? The fundamental. Okay. What is the value? The value is 5. This now is signaling to us, guys, that uh, this non-pure sine wave, this non-pure sine wave, sorry, not a pure sine wave, this just a wave, ne? Okay, is made up of the first and the what? Fifth harmonic. Okay, okay. So here we have 0, 2 Henry. Then the resistance is what? 10 ohms. Equation ifuna sibale ntoni? Okay, so it's 2.1.1. They want us to calculate the power absorbed. And so if we want to calculate the power absorbed, we can use as formulas E max 1, I max 1 over what? 2. Yeah, I'm writing them down. Yeah, I'm writing them all down. Yeah. Then times what? Is it times cos? Times cos. Anna. So plus we have the fifth harmonic, so we're gonna say E max what? 5 times I max 5 over 2 cos 2. And guys, the angle is the angle between the respective what? Current and what? Voltage. So it's the angle between this maximum EMF and this maximum current. And this maximum EMF of the fifth harmonic and the what? So, but with this formula, we have to know what? The current. Yeah, so we cannot use this one. Another alternative is to consider what? The resistance. Okay, is to consider what? The power, the power for the the resistive power, because the only thing that is consuming or absorbing power in a circuit is what? Is the resistor. So the formula will go P is equals to what? ERMS squared over what? Bear in mind, guys, I have to use the what? RMS value there. Okay, I have to use the RMS value. The formula efana nale define according to what? Ohm's law. P is equals to what? For a resistive circuit, V squared over what? R. Okay. Another one we can use is P is equals to what? I RMS squared. Ne? R. This is the same formula we derive in a resistive circuit, which is I squared what R. But obviously we're gonna use this one because I can calculate indoni RMS and then how do we calculate the RMS formula to calculate the RMS of a non-sine wave? K is equal to square root E max 1, then we square plus E max 2, then we square, divide that. Sorry, it's gonna be max what? 5 because we are talking of what? Fifth harmonic. I was supposed to say E max 5 divided by money by 2. Okay, so let us find OE RMS so that we can find the power absorbed because we have the resistance. Okay, uh, so OE max 1 is what? 140,44 squared plus OE max 5 is 80. Nanzana, you know, most your notation, the trick notation. The coefficient of the sine is the maximum value, which is 80, 72 squared over what? Over 2. So what is the RMS value, guys? 144. Oh, sorry. It's 114, comma 54. Sorry, one, it's like this one. So this is the RMS value of this what? Complex wave, of this non-pure sine wave. Non-pure sine wave. Okay. This is it's a what? RMS value. Now we can calculate what? The power that is absorbed. So we substitute into the power formula, okay, this one, okay. So P is equals to ERMS, which is 114, comma 541. Then we're gonna have to square it. Then we divide it by the what? The resistance. Yes, it's gonna be 1311, comma 964 watts. Or you can put it as 1 comma 3 1 kilowatt kilowatt is. I'm putting it in what? In kilowatts. So that is the power that is absorbed by what? The resistor. Because the only thing that is gonna be absorbing power here is what? The resistance. This one will be storing what? Energy. Okay. Then stay happy. Stay happy, na? It's in question just been.